Okay, what you can see on the screen is an application which is susceptible to SQL injection attacks. If I put a valid username in, it's at this URL, vmwaf.ukwest.cloudapp.azure.com. So it's running on a VM in Azure. If I put a valid username in here, like Planky, and I put a valid password, like my password, pick that one there. Again, all of this is insecure. It's been designed specifically as an insecure system. And I click login, then it logs me into the system. And it's logged me in, and it showed my last order and the credit card that was used to put that order in. So let's log out. Let's now try something like a query which I know will work. And that is quote or 1 equals 1 dash or dash dash. And let's put any old password in here. Let's just put some random characters in there. Okay, if I now try and log in, this is going to inject this SQL into the SQL statement which checks the usernames and the passwords. And that's going to have some magical effect because it's going to log me in. So let's click login, see what happens. And it's logged me in, it's printed out every order from every customer, and it has put the credit card information there as well. So this is not secure. How does this application work? Well, I think I'll draw a quick diagram to explain it. So this is paint, and I'm going to just change the size of the brush to that one. So we've got a user. I'm going to try and draw this as neatly as I can, bearing in mind it's quite difficult on a laptop. I've got a user over here. The user has got a laptop or a computing device that they use, and they are connected to the internet. So let's draw the internet here. Let's imagine that's the internet. And we've got a public, what's called a public IP address in Azure. Oh, let's get this right. That's called a PIP, a public IP address. It's connected to the internet. And that public IP address is connected to a network card, a NIC. And that NIC is part of a Windows server. Windows, which is running IIS, and it's running my SQL application. So there's the server. One of the things that that's a SQL application. That's my web application, ASP.NET web application, and that talks to a backend database. Well, it talks to the server, and that has got a database connected to it. And that database has got two tables, one called users and one called orders. So let's do the flow, shall we? So the user types onto the keyboard, puts their statement in, which is or 1 equals 1 dash dash. That statement gets passed into the PIP, into the network card, through the SQL application, and then fires off a query into the SQL server, which then does a query into the users table. And if it's a successful one, then it pulls out all the orders that are allied to that user. So that's the way the application works. Shall we have a quick look at the code? So the code that's running up here in my SQL application, the code that's running there has been designed to be very bad. You'd never want to do this in real life, but just to show you what happens. This is the query that gets executed. Select star from users where username equals blah and password equals blah. Blah and blah come from these two variables here, underscore username and underscore password, and they get filled in from this location here, from username and password in this screen. Okay, so let's do a log out, and then let's have a look at the code. So let's go back and have a look at the code. So let's bear in mind what we're doing here. We are doing a select star from users where username equals that and password equals that. Let's copy that. Let's put it into one here which I've already been playing around with, but let's just get rid of that and type the new one in. Now, it says where username equals and it's got that element in the string, which is this underscore username variable here, which came from whatever gets typed into the username box here. Whatever gets typed into there gets inserted into, where's it gone? Gets inserted into Visual Studio, gets inserted into that username variable there. And you can see what happens is we put a couple of quote marks, a quote mark at the beginning of it and a quote mark at the end of it. So what I'm going to do now then is in there, in that gap, I'm going to say quote or 1 equals 1 and then a comment delimiter. So what's the effect of this? Well, what the comment delimiter does is it says everything after this comment delimiter is considered to be a comment. So all of this is a comment and is ignored by the SQL parser, as is the actual comment delimiter itself, other than to tell it that it should ignore the rest of it. So let's have a look at the actual query that we've got. In fact, let's just delete this because that is of no use to us whatsoever. Let's delete it, make it much clearer. So the query that we're actually sending to the database is select star from users where username equals null. There's nothing there. So if we find a null username in there, or if 1 equals 1. Now what that means is if we find a username which is null, or we agree that 1 equals 1, then we're going to return the value true. And that is going to be associated with a property called hasRows in the data reader. Now let me just show you what I mean by that. If we come down here and we can see it says we create a data reader and we send the execute command off, and then we say if the data reader has rows. So if has rows is true, and it's going to be true because 1 does equal 1, that is true, then we'll execute that piece of code underneath there. So it's basically saying, look, it's saying if this returns true, then everything between there and there gets executed. So it says the label says login success. It closes the data reader. It sets the logged in variable to true, and then it returns true to the caller. So from that point on, this variable here, this logged in variable, is used to determine whether we're successfully logged in or not. This is a bad way of writing an application. You'd be much better off to use something like Azure Active Directory, which absolutely doesn't do this kind of thing. But this is the kind of thing that people were doing a number of years ago, and there are still lots of applications on the internet that are vulnerable to these kinds of attacks. Okay. So what can we do about it? Well, let's go and have a look at the application itself. I showed you this picture earlier. It consists of, should we do it in orange maybe? It consists of this big VM up here. So the VM has got all the stuff it needs. It consists of this bit of stuff over here, which is called Azure SQL DB. Okay, so what should we do? Let's, why don't we do something like this? Let's take this network card, attach it to a virtual network, and this is a virtual network that's running in Azure, called a VNet. Let's create a subnet on that virtual network. And I'm going to call that default, which is the default subnet that you get. And let's have another subnet on here. And I'm going to call this one WAF. And in there, I'm going to attach onto that VNet a web application firewall. And it's a thing called, see if I can draw this, write this out neatly. It's called Azure App Gateway in WAF mode. So it's got different modes of operation. One is to use it as a layer 7 load balancer with SSL termination and offloading and things like that. But one of its most common uses is actually as a web application firewall. And what this means is it will do deep packet inspection. And what it does is it takes a connection from here out onto the internet, and that is a pip. And that pip has a DNS name. And what we could do is delete our existing pip. Let's get the eraser. This one here, let's delete that one, so that one's no longer connected to the internet, and have this new one as the only method. So now if you watch the little man, let's do it in green, he's going to create his HTTP request with the SQL injection attack in it. Color green, brush. There's the HTTP request with the SQL injection attack in it. And what we will do with that is we will send it across the internet into this pip, this new pip that we've created, which will then transport it into the web application firewall. The web application firewall is connected to the application itself. It's connected up through this route, up through here. It'll go from the WAF into the WAF subnet, be routed across to the default subnet and into the network card, and eventually end up at that SQL application. But let's unwind all of that, go back here. So we are now at the WAF, and we will do deep packet inspection on this packet. So let's have a look what happens there. That means we go right deep into the internals of this packet here, and we see that it's got a SQL injection attack in it. And so what we return is a page that says, here's an ASP page, forbidden. That says forbidden. So we return that information. Let's get the forbidden message here. And that goes across the connection to the pip, across the internet, hits the user's laptop, and that's what they see. They have done something which is forbidden. So shall we have a go at building or including the WAF? Let's have a go at building in purple here. Look down by the pip. Let's have a go. Oh, let's get the brushes on here. Let's have a go at building the public IP address, the WAF, and let's connect it onto this subnet here, and let's make sure that the WAF knows about this VM that's up here. Right, so let's have a go at it, and we do that in the Azure portal. So let's go here. So I've got a resource group here. It's called RG for resource group -VM WAF, and that resource group has got some resources. It's not showing. Oh, that's actually a virtual machine. Sorry. Let's go to resource groups RG VM WAF, and you can see it's got a pip, a public IP address called VM WAF. It's got a storage account. It's got a virtual machine. The virtual machine has a disk for the operating system. You can see there it says OS disk. It's got a network interface. The network interface has a network security group on it, which allows HTTP traffic to come through. And it's got a connection to a virtual network. If we have a look at that virtual network, click it and have a look. We can see that it has got one device on it at the moment, which is at address 172.16.0.4. The address space for the entire thing is 172.16.0.0. /16. This is often confusing for people. Actually, let me get rid of that, and I'll just quickly explain what all that /16, CIDR, CIDR. Everybody's got a different way of explaining what all this stuff means. You know, when you get an IP address, you get 4 groups of 8 bits, don't you? So you might get, what did we have? 172. I can't remember what it was now. .16, wasn't it? Let's go back and have a look. It was 172.16.0.0/16. Let's go back and have a look at this. So you've got 172.16.0.0 and it says /16. So that is 16 bits and you load them in from this end. So this octet contains 8 bits. This octet contains 8 bits. This octet contains 8 bits and this octet contains 8 bits. This one is set to the value 0, this one is set to the value 0, this one is set to the value 16, and this one is set to the value 172. So what we're going to do is we're going to mask off these 16 bits here. That's what that 16 means. That 16 means coming in from the left-hand side, mask off those 16 bits. And it means that all of our addresses in this address space are going to start 172.16. That's how they're going to start. And then we've got another 8 bits here and 8 bits here. So we've got another 16 bits here that we can use for actual subnets. Well, in fact, what we can create from them is subnets and hosts that live in subnets. And I've gone for the really simple option of saying, let's have a subnet which is going to be 172.16. Well, we know that's going to be the case because that's the address space that was specified by these 16 bits here. This 16 was loaded in from the left-hand side and formed a mask over the top. So really that is a mask there, which is right over the top of those things. So you can't change them. So they're stuck at 172.16. And then what I'm going to do is I'm going to use, let's get the brushes back. I'm going to use this one here. Hopefully you can see I'm highlighting that as my subnet. And this one is going to be a host within the subnet. Okay, so I've got 172.16.0.n. N can be a host, a machine which has got an IP address. And this will be my first subnet. So my first subnet, which my default name for it is default. That's what I can't remember, but I think that's what Azure calls the first subnet that you create. Just by default calls it default, and you can give it another name if you want to. And then I'm going to have a .1.n, and that is going to be my WAF subnet. And you need to have a subnet purely for the WAF to go into. Okay, so hopefully that explains what all that stuff means. Sorry, and one thing I should have said, that this subnet becomes part of the whole number, and I would say that the address was 172.16.0.0/24, and the 24 is those. Let's do it in green. It's those 3 octets. So you mask off those 3 octets. We know it's always going to start 172.16 because that's what the address space is. That's the first 2. And then we can have any number between .0 and .255. Hopefully you can see that for the next octet. And I've chosen really simple numbers here because it's easier to do it on byte boundaries. Okay. So we're going to have 172.16.0. something or other is going to be where the hosts are, and 172.16.1. something is going to be where the WAF is. Now I can tell you a couple of things. One is that you can't have .0 as a host address because that's a broadcast address. I think .1 is for the gateway. .2 is for the gateway failover. .3 is the default router, because you'll always have a default router on the network, of course. And .4 is the first host. So if you create a VM, it's always going to start. The very first VM you create in a subnet is going to be .4. That's if you do it on a byte aligned boundary. Right, I'm hoping that makes sense to you because I seem to have rushed through that a little bit. But just bear that in mind. So 172.16.0 is our default subnet. 172.16.1 is our WAF subnet. So let's get rid of this. And let's go through and create. And so you can see here we've got 172.16.0.4. That is the network interface, which is called VM WAF 724. And I can tell you that that is the network interface which is connected to my VM. So at the moment, that's all we've got on there. We can look at subnets. If I click subnets here, you'll see there are two subnets. One is called default. It's at 172.16.0.0/24. Remember what that /24 was? Go back here. It's this green bit here. What shall I do it in now? Let's do it in light blue color. This light blue that I'm doing now is masking off these 24 bits here and saying they form the subnet. And then we can have 8 bits worth, this is over here, 8 bits worth of host names, host addresses, sorry. Let's go back again. Where was I? Oh, I was in here, wasn't I? And you can see we've got a WAF at 172.16.1.0/24. So all the addresses in the WAF will start 172.16.1. And I can tell you that the WAF will have an address of .4. It'll be 172.16.1.4. Okay, what's next? Let's actually create the WAF, shall we? Yeah, let's create the WAF. So I want to go all services. If I just type WAF, I'm sure that comes up with. So application gateways, yeah, that's the thing I want. I want to use an application gateway in WAF mode. So let's do that. Application gateways. So at the moment I have no application gateway. So let's add one. And we're going to go through some configuration of some basic settings now. So what shall we call this one? Let's call it App Gateway -WAF for VM WAF. I'm trying to put some kind of a naming convention in there. So it's of type App Gateway, and within the App Gateway it's a WAF, and it's going to be attached to the VM which is called VM WAF. Okay, the tier. This is how expensive it is. So there's standard v2, WAF, and WAF v2. We're going to go for the cheapest one, which is WAF. And then we specify how many instance counts we want. So how many instances of this WAF do we want? 2 is obviously a good idea, because if one fails, then the other one will continue to work. But we're going to reduce the costs here, and I'm going to set that to 1. The SKU size, that is a measure of how powerful this thing is. And we've got medium and large, so let's go for the cheapest option again, medium. They recommend an instance count of 2, but you don't need to have that, and for a demo, we certainly don't need it, just a demo. That's the subscription I'm going to use. I've already got an existing resource group with a lot of these things in them, so I'm going to find that. It's called RGVM WAF. There it is. I'll use that one. And all of my resources, my VM, my VNets, public IP addresses, all that kind of stuff, they're all in UK West. So I'm going to put this stuff into UK West. And then say OK. Okay, so the validation was successful, and it's now going through the process of building this thing. So now we get on to page 2, and it says, what is the virtual network that you are going to connect to at the back end of your of the WAF? So let's have a look at this. And we should see there is a VNet in the UK West called VNet VM WAF. So that's the one I'm going to choose. It says, of all the subnets which exist on that one, which one are you going to choose? I'm going to choose not default, and it's automatically chosen for me WAF because it knows it can't use default. It's got to have its own dedicated subnet. It doesn't have to be called WAF. I just called it WAF because that's useful. Okay, and look, that's at 172.16.1.0/24. So the 172.16.1 is the subnet, and the .0 is the range of hosts that I can have within that subnet. I can have up to 256 of them. 0 through 255 is 256 nodes. Some of them are reserved. You can't use them. I think you get 250, something like that. Okay, then we talk about the front-end configuration. Let me just go back here Let me get rid of this stuff. File new. Don't save that. So we've got our, let me get the brushes all going again. Brushes, come on, brushes. Black. So we've got our WAF. That's here. We know it's going to attach to a VNet. There's the VNet. We know it's going to attach to a particular bit of the VNet called the WAF subnet. We know there is another subnet on here, which is called default. Doesn't have to be called default, but that's its standard name. And we know that it's going to be connected to a PIP, a public IP address, which is going to be connected to the public internet. So here's the public internet, and that PIP is actually connected to that. And that obviously means if I've got a user out here somewhere with a laptop and a pair of arms and legs to type onto the laptop, they can get a connection through the PIP into the WAF subnet, routed through to the default subnet, and into any VMs which are connected to that default subnet. And I've got one connected, and it's called VM WAF. That's a VM that's connected to there. So all this stuff is called the front end, and all this stuff here is called, surprisingly, the back end. So let's go back to that, back to the portal. And we can see here, well, look, we've got a front-end IP configuration. It says, what type of IP address do you want it to be? A public IP address or a private IP address? Private IP address just means it's an internal IP address. I'm doing this for the public, so I'm going to pick a public IP address. Do I want to create a brand new one, or do I want to use an existing one? Well, we'll create a brand new one, and it automatically gives us a name because I haven't already previously set one up. So it's already given us an app gateway -WAF -VMWAF -IP. If I was going to stick with my naming convention, what I would really do is take that IP and put it onto the front here. I think it's saying you can't have a dash on the end. Yeah, there you go. So IP, because that's the type, for app gateway WAF VMWAF. Okay. And then it says, let's configure the public IP address. So we've got different SKUs. This one's going to be basic. Default timeout number, names and numbers and all that kind of stuff. And I'm going to call this, I'm going to call it VMWAF1. So it's going to be called vmwaf1.ukwest.cloudapp.azure.com. That's going to be its DNS name. Okay. It looks here as if I can't do a static assignment of the address. So a WAF wants to use, well, because a WAF is going to be using HTTP, that means everything's going to happen at layer 7. So do we really need static IP addresses to do stuff at layer 7? Because layer 7 can all be done through DNS URLs, can't it? Or the DNS portion of URLs. So there's no real need to have a static, and static costs more and they're a valuable resource. There's not that many of them. So it's going to dynamically assign addresses to me for the public IP address. So I'm just going to listen over HTTP on port 80. I'm not going to set up a second HTTP connection. The firewall status I'm going to enable. The firewall mode I'm going to put to prevention. So prevention, if you say detection, all it does is it puts some entries into a log saying you're being attacked. I think that's not very good. So prevention is better. That's where it does deep in packet inspection, sees that there's an attack going on, and sends up a message that says, forbidden, you're not allowed to do that. Okay, so that's all done. Let's say okay. Was all that working? Yeah, it was. And so now we've got a summary of everything, and I say OK. And now it's going to go away and build this for me. So it says it's submitting the deployment, it's all in progress, and we're waiting for that to now complete. It takes a little while, but it will complete. In this case, because I'm going to use the magic of video editing, it's going to complete amazingly quickly, in no time whatsoever. In fact, it's done it already. Look at that. Create application gateway. Okay, so if I refresh this now, you can see we've got app gateway WAF VM WAF. So that's our gateway. We need now we need to configure it. Now it's got a public IP address of that number there. It doesn't have a private IP address. It's part of a resource group. It's in UK West and it's on that subscription. So that public IP address there is the front end. It's this thing here. So what was it? It was 51. I can't remember the number. Let's get that there. Look. Copy it. Let's put it in our drawing, shall we? Put it here. Should we change the font size a little tiny bit? Put it up to 16 maybe. Come on. Can't change font size. Oh, here we go. It's 16. Oh, come on. So there we go. That's our front end. Let's go back here. And let's actually go into the configuration of the thing. In this case, just going through it. So the overview was just the overview of what it looked like. It's got its resource group name, front end IP address. It's also got a DNS name there. So I can just copy that, put it into this Word document, and just copy this part of it because we've got the IP address, haven't we, already? So let's copy that. Let's put that in our diagram as well. Put it about there. Maybe make it a little bit longer so that it fits. I'm sure. I think I must have missed the V off the front there. VM. Oh, you get the idea. It's VMWAF, isn't it? vmwaf1.ukwest.cloudapp.azure.com. Right. Let's go back. We can look at its configuration, and this is just configuration information, so we know it's in the WAF tier. We've already specified that information. It can be standard or WAF. We went for medium because that's the cheapest. There's medium and large. Gives you a little clue of what might be coming sometime in the future, doesn't it? Instance count. So how many instances do we want? In order to keep the cost down? 1. Do we want to enable HTTP 2? Nope, we don't. Let's go to the web application firewall. And these are settings to do with the web application firewall and how it works. So, tier, we've already done this, standard or WAF. We've already done that. Let's say WAF. Firewall status is enabled. Firewall mode is in prevention. Exclusions, these are things that we want to exclude. If there's some specific HTTP requests that we want to exclude, we can do that. Global parameters needs to be we need to inspect the request body. The maximum request size, I think it's 128K, probably says it here, 128K. So let's just say 128. So it'll always inspect all bodies. We're not going to upload any files, so let's just say 1 megabyte file limit for uploads. And then we'll save that. And let's just wait for that to complete. And those application changes have now been saved. Okay, now there are some rules here. We won't bother with them. We're going to use the OWASP 3.0 set of rules. You can see we can go to 2.2.9 or 3.0. And we could enable where we want to go into each one of those rules and specify which ones we want to use and which ones we don't want to use. I'm going to actually protect absolutely everything because that's bound to capture, if I say everything, it's bound to capture my my SQL injection attack. So let's just leave that there. We've already saved that. Now let's go to backend pools. This is very strange, isn't it? Look, I have just saved that, so I don't understand why it says that. I think this is a bug. We'll just go with that. So we go to the backend pools. Now, so the backend pools, what are they? Let's go back to our little diagram here. And remember this. Let's go in red. This is the backend. Oh, Oh, what's happened there? Let's go back to home. Brushes, get a brush. This is the back end. It's this bit here. So I've forgotten what I was doing now. Let me just have a look back here. Yeah, backend pool. So what are the rules that are associated with this backend pool? Is there a target? So if I click this backend pool, it says the name of this is called the App Gateway Backend Pool. I don't want to remove all the targets. So how do I want to target a resource in the backend pool to protect? So the ways that I can do that is I can specify either an IP address or a fully qualified domain name of something that's in the backend. I can specify a specific virtual machine of specific virtual machine scale set or an app service. So let's go for virtual machine. And that's now going to say select a virtual machine. So this is going to give me a list of all the virtual machines which are in that region, which was UK West. And there we go. I've only got one of them, VM WAF. And it says on that VM, which network interface do you want to protect? So let's have a look. And I've only got one of them, and it's that one there. It's that 172.16.0.4. We already knew about that, didn't we? Because I talked about it earlier. Okay, so that's all done. Let's save that. Now it takes a little while as well. And that's been done. So now let's have a look at the HTTP settings. And we just say that by default, cookie-based affinity. We're only interested in this really as a WAF, not as a layer 7 load balancer. So whether we've got cookie-based affinity or not is kind of irrelevant. We're going to allow HTTP protocol on port 80, so that's fine. What about the front-end IP configuration? So we haven't got a private IP configuration configured for the front end because we're connected to the public internet, so we are configured. It's called the App Gateway front end, and we know the address is 51.140.248.169. And if we go back to our diagram, we should see that there, 51.140.248.169. So that's our front end configuration. Everything there is fine. Let's go to listeners. Everything here is fine, just a standard HTTP port. Let's go to our rules. I think this gives us the same place as rule 1. Rule 1 is just basic. I can't remember whether I need to set. Let's click basic. No, that's adding rules. We don't need to add rules. So if I close that, takes us back there. Health probes, so we can probe for HTTP requests and see whether we get any. We don't really need to do that. This is a list of all the properties of everything that's been set. It never gives you a full list of properties. Locks we don't need to worry about. Automation script, this is if you want to automate the deployment of this through PowerShell or, let's have a look, it's PowerShell or, you get a number of files here. So we can do it with PowerShell, with there's a .NET class that can do this, Ruby, for some Ruby, why? Or using the Azure CLI, and then there's a parameters file, and there's an actual template file, and this is the resource group template file, which could be used for deploying this stuff. Okay, but we're not really bothered about that stuff, and then we get down to things like monitoring alerts and all that kind of thing. So I think in theory this should now be working. So if I go back to the overview and find its URL, back to the overview, and find that URL, which we've actually got on our in our document here, haven't we? There it is. So let's try that and see if it works. And I'm hoping I don't have to do any troubleshooting for something that I've misconfigured somewhere along the way. So let's go here, type that URL in, and go. So it's taken us to the location. So let's just try a normal login. So that's Planky, and let's have a password, my password, and let's do a login. And that worked. So that we would expect that to work, wouldn't we? So let's log out. Now that we've got a WAF in the way, because we're going through that URL, let's go back here, look. We're now going through, what color shall I do this in? Oh, I'm going to do this in orange. So look, down by this little guide, the bottom right hand corner here, our request is going to go through here, it's going to hit the pip, it's going to come into the front end, we're going to do deep packet inspection on this thing here, and we should spot a SQL injection attack, which is OR1 equals 1 dash dash. It should spot that, and it should return. It should not forward it to the VM WAF. It should send back to us a message saying forbidden, das ist verboten. So let's have a look and see what happens. Go back here. So let's put in OR1 equals 1 dash dash. Let's put in just any old random string of password there. And let's do a login. And forbidden, access is denied. You do not have permission to view this directory or page using credentials that you supplied. Okay, so that means that the WAF is working. Now, we do still have a problem, actually. And the problem is the old pip. Let's go, pip was the public IP address. Let's go back to our resource group. RGVMWAF, there it is. And we'll find the pip that was assigned to this. Public IP address, IP, app gateway WAF, VMWAF. Pip VMWAF, that's the one, that's the original one. Let's just go there. Get the DNS name, there's the DNS name there, look. I'll just copy that. Copy it again, paste it. Let's go up here. Let's paste it in. See what happens. Oh, it's taken us there. Well, that's fine. It's fine. Let's now do a SQL injection attack. Put some random stuff in here. And it works. Why does it work? Well, we didn't protect it, did we? We've actually got 2 pips. So I'm going to do this in black now. We've got this one here, which you can see I'm highlighting now, and that's a pip, and that goes through the WAF, and the WAF does this deep packet inspection on the data. But I've actually also got another pip connected to my network card up here about the VM. Look at the VM, and I'll go across and in here, and that's a different one. It's got a different URL. It's not mywaf1.ukwest.cloudapp.azure.com. I think it's vmwaf.ukwest.cloudapp.azure.com. Let's go back and have a look, see what it is. vmwaf.ukwest.cloudapp.azure.com. So what we would have to do to make this secure is delete that public IP address over here, PIP. We'd have to delete that. So if I get hold of the eraser and remove, you can see I'm gradually removing that. Remove the public IP address, remove the connection to the internet, and then it'll be safe because there'll be no other way. The only way to get to that VM will be to go from the public internet, will be to go from the guy down here. Whoops, let's get my brushes back. Sometimes it takes forever for that to work. From our guy down here, his only way into the system is through this pip, through the WAF, through the deep packet inspection. If all of that passes, then we go into the WAF subnet, get routed across the default subnet into the VM, and then the VM will respond and HTTP will stream out through this route onto his screen. Okay, I'm hoping that was useful and helpful for you. Hope you enjoyed it.